Hello and welcome back to lesson 22.2, shape, center, and spread. We're going to be going over a couple of distributions, just so you know what they all look like, because we're going to look at a couple of different types of data and how they look, and so you should know the difference between all of them. So let's say a distribution whose shape is basically level. It'll look kind of like a rectangle, so let's say we have our data. It'll look something like this. That would be known as a uniform distribution. The most commonly known distribution that looks like a mound in the middle with symmetric tails at each end. They call it tails, just because there's parts on each end, but it looks kind of like a bell shape. In fact, the most common is the symmetric or normal distribution. So even though they might say it's symmetric or it's a normal distribution, essentially they're referring to the exact same types of data. You might also have it be known as the bell-shaped curve. And it looks kind of like a bell. And then the last but not least is a distribution that is mounded. So it still has a mound, but it's not symmetric because one tail is longer than the other. This is called a skewed. And there's two types of skew distribution. One is known as a left skew, and the other is known as a right skew. This is the way I kind of look at it, because part of me is like, wait, the mound's on the right. Why is it called left? Think of it, well, the left side's a little empty. It's a little empty. Whereas for a right skewed, the right side is a little empty, or it's not as high. All right, so just keep that in mind. Write these on your notes so that way you can have these for the test, because if we do ask you about vocabulary or ask you to kind of describe a certain distribution, you want to know what those names are. Okay, and again, before we continue even further of actually calculating anything out, I also wanted to show you not only what the distribution looks like as far as left skewed, symmetric, or right skewed, but also when we do histograms, because we are going to be doing those in here, and box and whisker plots. I do want you to kind of see what that looks like. So whereas a left-handed skew, you'll see that this whisker, yes, it's like a whisker like a cat, this whisker is a little bit longer on the left. Oh, sorry about that. So that one's known as a left skew box and whisker plot, whereas this side is a little longer on the right, and that's for right skewed. And then symmetric, you'll notice they're about even. So both left and right are about even whiskers for our box and whisker plot when it's symmetric. Okay, so just keep that in mind, again, because in the next couple ones they might ask us to kind of describe the data, whether it's in a mound form or if it's in a box and whisker form. Okay. Alright, for explain 1, we're going to be making and analyzing a histogram. So that's the first thing we're going to learn how to make. And it says use a graphing calculator to make a histogram of the given data and then analyze the graphs. So rather than using a graphing calculator, I did want to show you a histogram maker that I'll show you how to use. It's completely online, which I like because we're probably watching this at home and you don't have a graphing calculator with you. So I'm going to show you an online histogram maker so that way we can make a couple of histograms and of course identify the shape of that distribution and identify what type of distribution that is, if it's left or right or symmetrical. Alright, so first of all they say make a histogram of the baby weights from Explore 1. So we have a bunch of data, but they just want to know about the baby weights. So I'm going to circle this and this. And this is the data I'm going to use. There's about, by the way, 20 numbers that we're going to enter into our histogram maker and kind of see what that looks like so we can identify the shape as well as what kind of distribution it is. So as you can see, there's plenty of online histogram makers. In fact, all I did was I Google searched easy histogram maker, and I'm going to select the first one that I see here. And here is just a tool. They're asking us to go ahead and, before you start, a couple of things to take into account: empty spaces, including 2 or more commas. Okay, don't include commas. All right, we won't. And if you want to compare more than one distribution, you can use this one. All right, so I'm going to start entering in some numbers like 3.3. I'm going to press enter, and hopefully I could be really fast in entering these in. But take some time, even though, yes, you're going to see the answer anyways. Take some time to, enter in some of the data, because for your homework and for some of the problems in your packet, you will be expected to use a histogram maker anyways, so get some practice in it. So I finished entering all those numbers, and it was not the funnest, but we did it. Let's go ahead and generate using that, and you'll see here is our histogram. Alright, so it calculated a couple things for us. I just wanted to kind of show you all the nifty things that this histogram maker can make. It can calculate your mean for you. That might be nifty to know a little bit later. It can calculate your standard deviation, which is also super nice. As you can see, it also measures our skewness. So noticing that the skew is it's 0 actually. So this might actually be even though I know it looks a little bit maybe not symmetrical, this might actually be symmetrical. So this would be a symmetrical or normal distribution. So the distribution has a central mound, and it looks pretty symmetrical to me. So that means it's a normal distribution. Because as you can see here, it kind of follows that. Now I would say, maybe the right looks a little empty, but it looks like for the most part it's kind of centered on. I would say maybe it's right skewed if this side was a little bit more empty, but because it does kind of feel a little bit more, and also we saw here that the skewness was 0, based on our histogram maker, we can also see that there's no really skew to this. So that's another nifty feature of using a histogram maker. Alright, so it says for part B, by examining the histogram, determine the percent of data that are within 1 standard deviation from the mean. That is to say that the percent of the data that is about 3.36 and 3.64. So let's go ahead and circle some of those numbers here on our data set that are between 3.36 and 3.64. So as you can see here, we kind of circled all of these values that are between that range. So there's about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 values out of 20. So let's go ahead and work that out as a decimal. And you should have gotten about 70%, or as a decimal 0.70. Alright, let's go on to part C. It says suppose that one baby weight is chosen at random. By examining the histogram, determine the probability that the weight is more than 1 standard deviation. Okay? And that they kind of gave that to us. Essentially, they took the mean, right? And they added the standard deviation, which was 0.14, and they got about 3.64. So let's look at our data and see what values are above or more than 3.64. Okay, and I'm going to highlight that for us. As you can see here, we were able to highlight about 3 values that were more than 3.64. So that's about 3 values out of 20. So let's work that out as a decimal and change it to a percent. And if you divided that out, you should have gotten 0.15 or 15%. So 15% of the babies weigh more than 3.64 because we only found about 1, 2, 3 that were above that range. All right, let's go on to part B. So here, again, they're going to ask us to make a histogram of the baby's lengths this time. So we're going to again use our histogram maker to do that. And make sure you include that last value too. So again, open up your Google search and go ahead and type in for a histogram maker. And I'm going to use the first one again. And go ahead and take some time and type in all the values that they give us for our baby's lengths. And if you entered all of the values in and press generate, you will see that you have about, this is your histogram. All right. And here they calculate again some mean for us, standard deviation, which is super awesome. In fact, yeah, it matches. See, it says mean is 20. Yes. And our standard deviation is about 1.4 approximately, right? And since the skewness is 0, I can already tell that the distribution has a central mound, as I can see. So that means it's a normal distribution. All right. That's for part A. Let's continue for part B. It says, by examining the histogram, determine the percent of the data that is within 2 standard deviations from the mean. All right, so that would mean that our standard deviation is about 1.4. Since there's 2 of them, we'll multiply that by 2. And that's about 2.8. So our mean was about 20. So 20 take away 2.8. And then, of course, 20 plus 2.8, which would be about 17.2 and 22.8. So there's that. I guess I was supposed to put the answer here. And then the work that I got to get those answers in there. My bad. So let's go ahead and find those values that are between those 2 ranges. And I'll go ahead and start highlighting those. So if you have a highlighter at home, go ahead and use it. And as we looked at this, we saw that there's about 18. Wow, there is 18 data values that are within that range. So 18 divided by 20 will give you a decimal. So go ahead and calculate that out. 18 divided by 20. And you should have gotten this as a percent after, of course, you change that decimal of 0.9 to a percent. Okay. And let's move on to part C, which says, suppose that one of the baby lengths is chosen at random. By examining the histogram, determine the probability that the length is less, actually less, than 2 standard deviations from the mean. Well, we found 2 standard deviations from the mean to be about, I believe, 17.2, because we worked that out in part B. So it's about 17.2. So let's go ahead and see what's below 17.2 in our data set. And as we can see here, there's really only one baby length that is actually less than 17.2. And there's only one, right? So here, that'll be 1 out of 20. So let's go ahead and divide that out. And you should get this as a decimal. And then that would be about 5% as a percent, of course. Just like it says here, stop and do the problems in the packet. We'll come back with the next explain in just a moment.